Okay, this geometry, section 10-2, areas of trapezoids, rhombi, and kites. And we're on page 735. Guys, just a quick review. A trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. Okay? A rhombi is the combination of it, well, it's any quadrilateral that has four sides equal. Now it includes squares, but it's not limited to squares. You understand that? And then a kite has two consecutive sides congruent. Both pairs of consecutive sides congruent. Okay? So we're going to talk about how to do the area of those. We stay away from perimeter on these, so that's good. But we can do perimeter with them, but it's not one of the things we do mostly. So let's talk about a trapezoid. I'm going to draw a trapezoid kind of the way we normally draw it. This is a trapezoid. These are the parallel sides, and these are called base 1 and base 2. Okay? The height is right here. It's all the way across. I could put it anywhere, but oftentimes we put it here because it splits it into a rectangle and a triangle. So it's nice to draw it that way so everybody understands that it can be the both. And we could add them up, we could do that. But simply, we have another formula of a trapezoid which says 1/2 the height, which is this, I didn't label it, the height, times base 1 plus base 2. Now it is key that you add the bases together. That's why they're in parentheses first. Okay? That is the key. And I can turn the trapezoid sideways. It does not matter. However you want to do it. But just a normal trapezoid, if we take a look here, let's say that we have a trapezoid that looks like this. They have one that looks like this. And this one, the legs are equal, but it doesn't matter. This is 58 centimeters. This is 28 centimeters. And the height right here is 30 centimeters. Okay? So to find this, I would say the height is 1/2, the area is 1/2 the height, which is 30. And I add the bases together, which in this case is 28 plus 58. Okay? Now it's awesome when we get even numbers, because anytime we take 1/2 of them, that's great, isn't it? So 1/2 of 30 is 15. I can do that outside, but then I have to add these together before I multiply. And I believe that is 86, is that right?
Yeah.
Okay. And if I take 86 times 15, I get what? 1,290 centimeters squared. Okay. All right. Okay, so if I gave you a problem, this is for real now. It looks like this. Now, wouldn't it be wonderful if they were all that easy? But it's not going to be that easy. I'm having a hard time drawing this. Okay, here we have a base of 10 inches, and this is 8.5 inches. Okay, and this is 4 inches. Okay, now what is the problem with this? We actually do have the height. What is the height?
4.
It is 4. What don't we have?
The bases.
We don't have this little base here, do we? Okay, so what I could do is cut that off, right? And I could cut it off at an equal measure, okay? How long is this? 4 inches, correct? 4 inches. We do not know this value here, so we'll call it x. Now we know the whole thing, right? Right? We know the whole thing. Okay? And this is x, isn't it? Okay. So what kind of triangle is this? It's a right triangle. So we could use the Pythagorean theorem to find this little piece right here, right? So I'm going to move this 10 inches out. We could find this little piece here. How does that help us?
You could subtract and find 1x.
All right, that's right. We could subtract that from 10 and find this x, which is the same as that x, right? And then we'd have our bases. So let's use the Pythagorean theorem. We would take 8.5 squared, correct? Subtract 4 squared, and that would give us, we'll call that, we'll call it L. L squared, correct? 8.5 is the hypotenuse. Leg squared plus, yeah, and you see what I did there? I kind of switched the formula on you. What did I, instead of doing leg squared plus leg squared, I took hypotenuse squared minus leg squared, correct? Okay, so what is 8.5 squared?
72.
About 72.25?
Yep.
Minus 16 equals L squared, correct? Right?
Yep.
And so what is 72.65 minus 16?
56.25.
56.25. Now what do I need to do to that to find L? I use a square root. I heard it over there. I don't know who said it. Somebody said it. Find it. Thank you, Kagan. Would you find the square root of 56.25?
7.5.
And does it come out even?
Yeah.
Oh, that works out great. So what do I do with that 7.5 now? I take 10 minus 7.5, don't I? Which is what? It is 2.5. So this little value of x is 2.5, making that 2.5. Now I can find the area. What's the area? 1/2. What's the height? 4 times, what's base 1 plus base 2? 2.5 plus 10. Don't forget, you got to go back to the 10, right? Aubrey, you got to go back to the 10. Nelcha, are you okay?
Yeah.
All right, so then we got 1/2 of 4 is 2, and 2 times 12.5, is that correct? What is 2 times 12.5? It is 25, so the area of this is 25 inches squared. How was that? Works pretty good, doesn't it? Okay. All right, so we're going to talk about the area of a rhombus and the area of a kite. Okay, we're going to take a look at a rhombus. Rhombus looks like this, where all the sides are equal, right? And a kite looks like this, and they turn it sideways in the book. But a kite, this side is equal to this side, and this side is equal to this side. So difference of the two, okay? But each one of these has diagonals, okay? Here's the diagonal of here's the two diagonals of the rhombus. Now, are the diagonals congruent? No, they are not. And here is the diagonals of the kite. Are those two congruent? No, they are perpendicular, by the way, but they're not congruent. Well, it turns out that these two guys have something in common. That the area of these two guys is 1/2 times diagonal 1 times diagonal 2. So we say 1/2 d1, d sub 1, d sub 2. That's kind of nifty, isn't it? That they both, I mean, we don't have to really, we can pretty much memorize the same formula, correct?
Yeah.
All right, so now that we know that, all right, what happens is that we can find the area of them by multiplying the diagonals, okay? So let's say that we have a rhombus. Oops. And it looks like a kite, doesn't it? But it's a rhombus. Okay. Here's the diagonals, okay? And this guy right here is 10 feet, half of it, and this guy is 12 feet. I'm going to mark this as congruent, and this is congruent. Okay? So this is 12 feet. I don't know if you can see that. This is 12 feet, this is 10 feet. Okay? What's that? This one's 12 from here to here, and this one's 10 from here to here. Alright? So, if I do the area is 1/2. What's one of the diagonals? If it's 10 feet from here to here, it's 20. And if it's 12 feet from here to here, how far is it from here to here? 24. Now, if one of these numbers happens to be odd, Angel, one of these numbers happens to be odd, can I move them around so I can put the 1/2 with an even number?
No. Wait, yes?
What property says I can move them around? Tyra? The community property says I can move them in anywhere I want. So what's 1/2 of 20? 10 times 24, which is 240. And my label is feet squared. I know you can't read that. I gotta make them bigger or get a different marker, one or the other. Okay? Seems pretty straightforward, doesn't it? Okay. What would happen if I said that one of the diagonals was twice as long as the other one? Okay, so I have a rhombus, let's try it like this, and I said that one of the diagonals was twice as long as the other one, and the area of the rhombus was 169 square millimeters. Could I find the lengths of the diagonals? So diagonal 1 would equal what, and diagonal 2 would equal what? How would I do that if I said that one diagonal was twice as big as the other one? What would this diagonal be? That one would be x. What would this one be? Twice as big. 2x. Okay? Would be 2x. So the area would equal 1/2 times 2x times x, correct? But we know the area. What is the area? 169. So I can plug that into formula. What is 1/2 of 2? 1. So what I have on this side is just x squared. I have on this side is 169. So what does x equal? Square root of 169, which is what? 13. Right? Diagonal 1 is 13. How big is diagonal 2? 26. Now, that's fairly easy, isn't it? What would happen if I went to a trapezoid? I went to a trapezoid and I told you that the area was 177 centimeters squared. And I told you that the height, this height right here, was 13 centimeters. And this was 11 centimeters. And I don't know that one. How could I find that? This is x, this is 11, this is 13.
You take 177 equals, then it'd be
A half times
13
13 times
x plus 11.
plus 11. Okay? This one's a little harder, isn't it? Can we do a half of 13? What is it, like 6.5?
Yeah. 6.5.
6.5? Okay. And what's the best way to do this? There's two ways that we can do it. Kellen, we can distribute the 6.5 throughout both numbers, or we can simply just divide both sides by 6.5. I do not know what 177 divided by 6.5 is. Can you tell me?
27.2.
Does it keep going?
Yeah.
It goes on forever.
Yeah.
Okay. So keep that in your calculator, and then what are you going to do to solve for x? Minus 11. So it'd be 16.2,
Yep.
and that would be the length of x, right? So that'd be 16.2 centimeters. So we can find that. All right? Any questions? Dylan, do you have any questions? You're the one. Okay. All right, so I'm going to turn you loose here. I'm going to do page 739, and I'm going to have one of you guys write this up there, but I'll put it up there. Page 739, 8 through 13, comma, 17 through 20. Okay? I am giving you tomorrow to work on it, which kind of concerns me, because several of you will be gone tomorrow, is that right? Or nobody's gone? Just Dylan? Just two of them? Okay. All right. I don't know, bring something else to work on.